So in these lectures we will be covering topics of number theory, and the book which I am referring to is Elementary Number Theory by David M. Burton. So in first lecture we are covering divisibility theory in the integers. My first topic is division algorithm. What is division algorithm? Given two integers a and b, with b is greater than 0, then there exist unique integers q and r satisfying a is equal to qb plus r, where 0 less than equal to r less than b. It is strictly less than b. The integers q and r are called respectively the quotient and remainder. This q is your quotient. When you divide a number by another number, then you get a quotient and a remainder, and remainder is strictly less than b. So this is called division algorithm. Corollary to this result is, if you have this b not equal to 0, that means it can be negative also, then this result becomes a is equal to qb plus r, where 0 less than equal to r less than mod b. In that case we take mod b. Next we have greatest common divisor. We can also say GCD. So if you have two numbers a and b, then d is called GCD of a and b if d divides a and d divides b. And if c is any other integer such that c is dividing a and c is dividing b, then c should be less than equal to d, because your d is greatest common divisor. Next, if d is GCD of a and b, then you can always find integers x and y such that d can be written as a linear combination of given two numbers, that is a and b. Next important result is Euclidean algorithm. Repeated application of division algorithm is known as Euclidean algorithm. It is named after the mathematician Euclid. So now let us work an example to know how this Euclidean algorithm works. So we will find GCD of these two numbers 12378 and 3054, and we'll see how this algorithm works. So I have used this long division method which we have been doing in our schools. This 12378, we are dividing it by 3054 by using repeated division algorithm until we find a non-zero remainder. The last non-zero remainder 6 is called the GCD of given two numbers. So this method we already know. Euclidean algorithm says that you just write these steps in the form of division algorithm. You just repeat these steps. You are doing division algorithm again and again. You just write those steps. 12378 is equal to 3054 into 162 plus 4. Then 3054 is equal to 162 into 18 plus 138, then 162 is equal to 138 into 1 plus 24, and so on. You write all these steps. In the last non-zero remainder 6, here in this case it is 6, is the GCD of given two numbers. Just writing in this way is called Euclidean algorithm. Now, how we write GCD as a linear combination of given two numbers? In that case, we use reverse Euclidean algorithm. Why do we call it as reverse Euclidean algorithm? Because we go from down to up in this Euclidean algorithm. So let us see how we do. Let's see previous slide. Here 6 was your GCD of given two numbers. So 6 can be written as 24 minus 18 into 1. Then we can substitute value of 18, and then let us see how we are doing. 6 is equal to 24 minus 18 into 1. 24 is equal to 138 minus 24 into 5 into 1. Open this bracket and just combine the same terms, 24 into 1 to 24 into 5, because 24 into 6 and this as it is. Then substitute the value of 24, then again open the bracket and multiply. Then combine the similar terms. This 138 into 6, 138 into 1, combine them, it becomes 138 into 7. Then substitute the value of 138, again open the bracket and combine the similar terms which have similar coefficients. So again combine, and so finally what we will get finally these two numbers 3054 and 12378 and with some coefficients. So 12378 into 132 plus 3054 into minus 535. So here x is 132 and y is minus 535. Next very important result is Diophantine equation. It is named after the mathematician Diophantus. So any equation in one or more unknowns that is to be solved in the integers is called Diophantine equation. So simplest type of Diophantine equation is linear Diophantine equation in two unknowns like ax plus by is equal to c. Now we want to find the solution of a given Diophantine equation. So solution of this equation means value of x and y which is satisfying this equation. Let us see example. 3x plus 6y is equal to 18. It's a linear Diophantine equation in x and y. So we want to find value of x and y such that when you substitute value of x and y you get 18. So here we have 3 into 4 plus 6 into 1 is 18, x is 4, y is 1. Then next solution is 3 into minus 6 plus 6 into 6, that also gives you 18. 3 into 10 plus 6 into minus 2, this is also giving you 18. So we have three solutions of this Diophantine equation. But let us see another example. 2x plus 10y is equal to 17. It has no solution. Why it has no solution? Because see the left hand side. You put whatever value of x and y. Any integer value of x and y, you will get an even number in the left hand side. But the right hand side is a odd integer. It is 17. So solving this Diophantine equation is not possible. So what is our next question? Our next question is, what are the conditions under which a Diophantine equation is solvable? Let us see this result. The linear Diophantine equation ax plus by is equal to c has a solution if and only if d divides c. You have this Diophantine equation ax plus by is equal to c. So what we are doing? We are finding GCD of a and b and checking that the GCD is dividing right hand side or not. So if it is dividing right hand side, then this equation has a solution. And if the equation has solution, then GCD should divide right hand side. It is if and only if condition. Further, if x naught y naught is any particular solution of this equation, then all other solutions are given by x is equal to x naught plus b by d into t. A, b is given to you, and d we have already found GCD of a and b. And y is y naught minus a by d into t. Here t is an arbitrary integer. Let us see few Diophantine equations where we need to tell whether they are solvable or not. So we have 6x plus 5y is equal to 22. So what that result says? It says you find the GCD of these two given numbers a and b and check if it is dividing right hand side or not. So let us find GCD of 6 and 5. 6 and 5 are relatively prime. So their GCD is 1 and 1 divides 22. So solving this is possible. Next, GCD of 33 and 14 is also 1. There and 1 can divide right hand side. So it can be solved. Third, let us find GCD of 14 and 35. Its GCD is 7 and 7 doesn't divide 93. So this Diophantine equation cannot be solved. Now we want to determine all solutions in the integers of a Diophantine equation. Consider this equation. 24x plus 138y is equal to 18. So how to proceed? Same way we are finding GCD of 24 and 138 by using Euclidean algorithm. GCD is 6. Then by using reverse Euclidean algorithm, we are writing 6 as a linear combination of given two numbers 24 and 138 and those coefficients of 24 and coefficient of 138, that values are your x naught and y naught, that is particular solution. So by that previous theorem, by this theorem, x is equal to x naught plus b by d into t and y is equal to y naught minus a by d into t. Let's use this result. So x is equal to x naught, which is your 18, plus b by d. B is 138 and d is GCD, which is 6 into t. So 18 plus 23 into t, and similarly y is equal to minus 3 minus 4t. So t is an arbitrary integer. You put any value of t, you will find a solution of the given Diophantine equation. Now another exercise is to find all solutions of a Diophantine equation in positive integers. Let us work upon this example. 18x plus 5y is equal to 48. So same way we are finding first GCD of 18 and 5, which is 1. Then writing GCD as a linear combination of given two numbers. From here you will get particular solution. This is x naught, this is y naught. Then by using that theorem you find value of x and y in terms of t. Now because we want positive solution, so x greater than 0 and y should also be greater than 0, both of them should be greater than 0 simultaneously. So if 96 plus 5t is greater than 0, then you find t greater than minus 19.2, and from the second one you get t is less than minus 18.7. So if t is satisfying both of these conditions, then t is equal to minus 19. Substitute the value of t in x and y, you get x is equal to 1 and y is equal to 6. So this is positive solution. Now you may have a problem where finding positive integer solution is not possible. For example, 123x plus 360y is equal to 99. Let us work upon this example. So first find GCD of 123 and 360, which is 3. Then write 3 as linear combination of given two numbers. From here you get a particular solution. Then find value of x and y in terms of t. Because we want positive solution, so x is greater than 0, y is greater than 0 simultaneously. From here we get t is greater than minus 11.275 and t is less than minus 11.3. So if t is greater than minus 11.275 and t is less than minus 11.3, so you can see that such a t is not possible.